Hello everyone, my name is Trinayan Barua and I'm a third year PhD student from Northeastern University. I'm also a developer of the MGPUSim simulator. In this tutorial, I'm going to take you through the modeling of the components in MGPUSim. We are also going to do a few hands-on experiments that will try to showcase the different features of the simulator. The first thing that we are going to take a look at is how the repositories in MGPUSim are organized. This is helpful for anyone who is wanting to make software changes for his or her own research work. So here's the repository map. At the top level, we have the Akita. So this is the repository that contains the simulation engine. So this handles all the event-driven simulations. Then we have the Viz repository, which is responsible for handling all the visualization related tasks. So this is something that is part of the Dyson tool, which Yifan will cover later. Then we have the util repository. The util repository contains basic functionalities that would be used by all the other repositories. So common basic functionalities. Then we have the mem repository. The mem repository models basic caches and DRAM controllers, which would be used by the GPU. Then we have the NOC repository. The NOC repository models both the intra-GPU and inter-GPU network in MGPUSim. And finally, we see that these mem repository, NOC repository, all use functionalities from the simulation engine, which is described in Akita. As for the GPU part, which is the core part of the GPU simulator, we have the MGPUSim simulator. Now, the MGPUSim simulator would use components or code from all of these different packages. For example, for modeling the caches and DRAM controllers, it will use code from the mem repository. For modeling the network used for connecting the different components in the GPU, it will use the NOC network. It will also use the NOC repository for connecting, for describing the connections between multiple GPUs. As for handling the simulation events, it will use code from the Akita repository. So you can see why this kind of repository structure is very good for scaling the development. For example, if a researcher wants to use the Akita framework to design his or her own accelerator model, then he can reuse the simulation engine from the Akita framework. They can, if they're just modeling basic caches, they can reuse code from the mem repository. For connecting the components for their new design, they can reuse code from the NOC repository. So all they have to do is just swap out the MGPUSim part here with the accelerator model and then use the other features of the simulator as it is. So this is very helpful for development and is something we envision that as the user base grows, more and more people will be taking advantage of this flexibility. In the next tutorial, we're going to look at how to run a basic GPU simulation in MGPUSim.